Okay, let's take a look at simplifying expressions. To simplify expressions, we may need to combine like terms. So we need to know what like terms really are. Like terms basically have the same variables to the same exponents, so they look the same. So just loosely speaking, like terms have the same variables with the same exponents. For example, here's what I mean. If I have 3x and 5x, these guys are like terms. The 3 has an x to the first power, the 5 has an x to the first power, so they are like terms. Let's say I have 3x and make this guy 5x squared. These are not like terms because this guy had an x to the power 1, whereas this guy has an x squared, so they are not like terms. How about 3x and 5y? Well, that right off the bat, they are not like terms. And why is that? Because this guy contains an x, this guy contains a y, they don't even have the same variable. How about 3 and 5y? Well, are they like terms? Do they contain the same variables to the same exponents? No, because this doesn't even have a variable, so these two are not like terms. How about 5z and negative 22z? Well, they both contain z's, and the z's have the same power, so yes, these guys are like terms. So basically, same exponent and same variables make these two pieces like terms. Okay, how about 5xy and 10xy? Well, they both contain same variables to the same power of 1 for each one, so yep, these are like terms indeed. How about 5xy and 10yx? Well, they both contain the same variables, they both have the same powers. The order seems a little bit different, but remember, when you have no operation shown, there's automatically multiplication between them. So the order in which you multiply doesn't matter because multiplication is commutative, so this 5xy and this 10yx are really like terms because you can think of that as, oh, I'm just going to reorder it and write it as 10xy. So yep, they are like terms. So now that we know what like terms are, or what things are not like terms, we can go and simplify expressions because all we have to do is combine the like terms and leave the other ones alone. Let's look at some examples. Combine like terms if possible. 5x plus 7x. So you've got two things that are definitely like terms because they both have the x. 5 of them plus 7 of them is going to give me 12 of them. So I ultimately get 12x. 19y minus 5y, all I'm really focusing on is what are called the coefficients, the 19 and the negative 5. The y's are like terms, so 19 minus 5 is 14, and I end up with 14 y's. Like terms, combine the coefficients and attach the variable at the end. How about 5x minus 7y? Well, it says combine like terms if possible. Here, it's not possible because these two guys are not like terms. One contains an x, the other one contains a y. How about part D? 25z cubed minus 10z cubed. Again, the z cubes are the same. I only got to worry about the 25 minus the 10. So I end up with, I guess, 15 and attach the z cubed. I had 25 of these guys minus 10 of these guys, leaves me with 15 of those guys. I don't touch the exponents of the z's. I just copy it right down because they are like terms. I'm just combining them. Okay, how about I've got 15z minus 15z. They're definitely like terms because they both contain the z. So I'm basically thinking, what's 15 minus 15? 15 minus 15 is 0. I have nothing left. If you want to attach the z, kind of like we attach the variable next to it here, that's fine too. I end up with 0 z's, and 0 z's basically means just 0 because 0 times z, there's an invisible times in between them. Anything times 0 ends up being 0 anyway, so 15 of them, take away 15 of them, you're left with nothing, with 0. How about part F? It looks like they're all like terms, and the x squared really has an invisible coefficient 1. So basically I'm looking at 4x squared plus 1x squared, because I want to do 2 at a time, work left to right. So I got 4 of these guys plus 1 more of that guy. That gives me 5 of those guys, so that's 5x squared. And then I bring down the other minus 5x squared. Now this problem F is, this expression is kind of like part E. I got 5 of them, I take away 5 of them, so I end up with none of them. I end up with 0. Let's simplify some expressions that may contain like terms. So right off the bat, we know there are some like terms. This guy and this guy are like terms. And this guy and this guy are like terms because these two have the same variable, these two don't have a variable at all. So I'm going to focus on x plus 2x. That's going to give me a total of 3 x's. And then I'm going to focus on 5 minus 3. 5 minus 3 is 2. So I end up with 3x plus 2. A positive 5 minus a 3 is a positive 2. So I end up with 3x plus 2. How about part B? We've got this guy and this guy that are the same. Keep in mind you have an invisible 1 there. And then we also have this guy and this guy that are the same. So I've got 1x minus 5x. So I'm basically thinking of this as I have a 1 and a negative 5, and then I'm going to deal with the x's later. If you don't like the 1 minus 5, you can do the change business. So now you're adding two numbers with opposite signs. Take the difference. They have a difference of 4 and the negative wins, so I get a negative 4. Which means these two pieces combined really give me a negative 4x. All I did was add the coefficients, 1 plus a negative 5. Here I got a negative 5 and a 7, so I basically have negative 5 plus 7 on the side that I'm thinking about. This is difference of 5 and 7. That gives me a 2. Which one wins, the negative or the positive? The positive one wins, so I end up with negative 4x plus 2. Alright, part C, it looks like we need to use the distributive property and multiply that through and then see what happens. So I've got negative 2 times a positive 3, which is a negative 6. Attach the z next to it. Then I've got a negative 2 times a negative 6, which is a positive 12, attach the y with it, and bring down the negative z that was waiting. Now I can see I do have like terms here and here. Remember that coefficient of z is a negative 1z. So when I combine like terms, I basically have a negative 6 and a negative 1 in front of the other z. If that's bothering you, you can do the change business. And that gives you negative 6 plus a negative 1, which is a negative 7. So negative 6z and negative 1z is really negative 7z. And then I bring down the 12y since I can't do anything further because they are not like terms. Okay, part D. I have a bunch of negatives going on, so we're just going to calm down and kind of focus on how to deal with them. This negative 3 and negative 3, I can't do anything here first because I have parentheses, and when I go to the parentheses there's nothing to combine because they're not like terms, so this negative 3 stuck to the parentheses must be distributed first before I do anything. Now if that's bothering you, is that a minus 3 or a negative 3? Well, same thing. Why don't we do the change business so that we can clearly see what it is that we are distributing into the two pieces. So I have a negative, I'm going to save this and bring it down in a second. Negative 3 times a positive 4, that's a negative 12. And I have a negative 3 times a negative x, which is a positive 3x. And then I still have this guy that I haven't touched and this guy that I haven't touched. So all I did was take the negative 3 multiplied by 4 to get a negative 12. negative 3 times, really there's a negative x there, and again, if that's bothering you too, you can do the change in there as well and make that a negative 1x. Negative 3 times negative 1 will actually give you a positive 3 and attach the x. Now that I have the distribution done, looks like I have like terms here and here, which means I get two numbers that I'm adding with the same sign, add them up and keep the common sign that's negative, and then bring down the 3x, and nothing more we can combine from there on. Okay, part E is kind of similar to part D, except part D had those negatives sort of throwing us off. Here we have that fraction to worry about. Again, focusing on the parentheses, can't combine like terms, so why don't we distribute this 3/4 into both pieces? And if that negative is throwing you off, again, do the change business. So I got this guy distributed into the first term and distributed into the second term. Now let's focus into each piece and say, okay, in the first one I have negative 3/4 times 4x basically. And since I have the option of multiplying the items as I please and grouping them with the association property, and this is 4 times x also, I'm just going to think of this as 4 over 1, and then the 4 from the numerator is going to reduce with the 4 from the denominator. So ultimately what I have left is a negative 3 times x, which is negative 3x. So when all of the first one multiplies with all of the first one inside the parentheses, things cancel out, and I really just get a negative 3x nicely. Now let's do the same thing with the second guy. Negative 3/4 times the second guy waiting around, which is a positive 8. And again, I can think of that as 8 over 1, and then do my reducing. 4 into 4 goes once, 4 into 8 goes twice. So I end up with negative 3 times 2, which is negative 6, over 1, which I don't have to put there anyway. So now I have plus this guy times 4x gives me negative 3x, bring down the plus, negative 3/4 times 8 gives me a negative 6, and I didn't touch this guy, I didn't bring it down, and this one either, I didn't bring it down, and I'm going to do that now. So now do we have like terms? Yeah, looks like I got this guy and this guy that are like terms. And I'm adding a bunch of stuff, but this and this don't have the same sign, so even though it's adding them, I actually take their difference and then the bigger one wins. So the difference of 2 and just 6 by itself is 4. Bigger in absolute value was negative 6, so that's a negative 4 that wins. Plus, bring down this guy, bring down this guy. So I basically have negative 4 minus 3x, if you want to write it like that, is okay. Or even if you want to stop here as negative 4 plus a negative 3x, leaving it as a plus negative 3x, that's fine too. Alright, here we don't have any distribution involved, but we do have like terms with the a's and like terms with the b's. So the a's, it looks like I have a 1a and a negative 1a, so they're just gonna cancel each other out. I had a minus a basically. With the b's, I have 3b's minus 1b, that leaves me with 2b's, and I'm good to go. So got one more. How would we simplify this? Well, I have 8x upstairs, and if I don't have anything between the two pieces, there must be a multiplication involved. So I have 8 times x over 8, which means just like I can reduce things the way I do here, I can reduce the 8 and the 8 and be left with just 1x over 1, or just an x if you'd like. So the 8's cancel out and I'm left with an x. Similarly here, I can cancel out the 2y's, go away, leaving off a 1, And I have negative 3 over negative 1, which is just a 3.